Section 11.2, 11-2 on my grid. Oh, look at this pretty color. It's teal. So this is some different, what do we call this? Techniques for evaluating limits. So techniques for finding limits. So I'm going to go through a lot of examples, guys, so you got to kind of, but you just kind of have to know how to do it. So limits, so say they ask you to find the limit of x squared minus 9 over x minus 3 as x approaches 3, right? So what happens when I plug in 3? I get undefined, okay? So so if it's undefined at 3, either I have a hole in the graph there or I have an asymptote, okay? So to figure out what I have, anyone know what I should do? Factor, okay? That's right. So you factor the top if you can, okay? Which factors to, what does the top factor to? X plus 3 times x minus 3. And then you are, you are allowed to cancel out this x minus 3. Now, in the past, you might have an asymptote there, or you might actually you have a hole in the graph at x equals 3. Okay, so this equation looks exactly like the line y equals x plus 3 everywhere except at 3, right? So if I were going to graph this function, all right, if I were going to graph this function, it looks just like y equals x plus 3 except at 3, it's got a hole, okay? At 3 comma what does it have a hole? What if I put 3 in there? What do I get out? 6. Okay, 3 comma 6. I have a hole. So as I get closer and closer and closer to 3, what y value do I get closer and closer and closer to? 6. Okay, so that is the limit. The limit is 6. All right. So you just simplify and then you plug in. Easy enough. That's really what you have to do in most of these cases. You have to simplify if it's undefined or you can't find the limit, and then you plug in, you get it down to where you can find the limit, okay? So that's one type of questions on that. Easy enough, straightforward enough, okay? So what if this is one that you may or may not remember how to do. What if I have the limit, if I have a cubic function? You guys, limit as x goes to 1 of x minus 1, x cubed minus 1. So if I plug in 1 in here, do you see that I get 0 over 0? Okay, which is indeterminate. You can't tell anything about it. So then you have to factor the x cubed minus 1. Does anyone know that? Do you know how to factor x cubed minus 1?
Is it x plus 1, x minus 1, x plus 8?
No. Yeah, there's a formula. There's a couple formulas. I would memorize these formulas, okay? Or at least you see them a lot in this class. I think a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Where did that come from? It's just a formula. I teach it in advanced algebra 1, okay? But it's you can prove it algebraically, okay? Just by using long division on a cubed minus b cubed, and then divide that by a minus b. I can figure it out. And a cubed plus b cubed, okay, is equal to a plus b times a squared minus ab plus b squared, okay? So in this case, a is x, right? A equals x, and b is equal to 1. So this is a form in which you have a cubed, because what's 1 cubed? 1. So this bottom, you just have to kind of know how to factor the bottom. So this is equal to the limit as x goes to 1 of x minus 1 over a, so this is a cubed minus b cubed, so it's going to be x minus 1 times x squared plus 1 times x x minus 1, sorry. X minus 1 times 1 times x, which is x, plus b squared, which is plus 1.
What is that? What are those equations for? Like
Perfect cube trinomials. The difference of two cubes is sum of two cubes.
oh, yeah, the difference.
Guys, but, and so then these cancel out, and I get 1, and then I could plug in my 1 in here, and I get 1 over 1 plus 1 plus 1, which is 1 over, not 1. What's 1 plus 1 plus 1? 3, okay? You get that limit is equal to 1/5. If you don't remember those difference of two cubes, anyone tell me a different way I could have done that? How else could I have done that? How could I figure out how x cubed minus 1 factors? Do you remember synthetic division from first semester? Hello? I could have put a 1 out here. I said, well, I think 1 is going to be a root of this. And then I would put my coefficients. 1x cubed, 0x squared, 0x minus 1. Remember that? Hello? Okay. And then you draw your line down here, and you bring this one straight down. Okay? 1 times 1 is 1. Add those together, you get 1. This times this is 1. Add those together, you get 1. This times this is 1. And you get 0, which means that this, since I'm assuming that 1 is a root, this is the other factor, so this factors to x minus 1, right, times 1x squared plus 1x plus 1. See it? Okay? So that's another way I could come up with this. Yeah? You remember that? Okay? But so these would be kind of nice formulas to memorize, but they come up a lot too. And so all you have to remember is a cubed minus b cubed. You put a minus b, and these things are a squared plus ab plus b squared. It's a plus b. This sign flips to being a minus sign. That's the only difference. This is the same as it. This sign is the same as it is here, and this sign is the opposite of what it is here. That's how I remember. I just remembered them this year for the first time. Yes, Lily.
So the limit is 1/3, but there would be a hole at 1/3.
That's right. There
So
would be a hole, but that doesn't mean you can't have a limit there, right?
So
Okay.
is the limit just whatever the equation ends up being? when you
Yeah.
look at x?
Well, the limit at that point, yeah. Because basically, if I, what do I get if I graph? Is there a hole? Is there a hole?
Yeah, a lot of next minus.
Yeah, you could cross out x minus 1, so there is a hole at x equals 1. So if I were to graph this, I'm not exactly sure what this does it look like? If I graphed 1 over x squared plus x plus 1, I think it might, let me guess, but I'm guessing that it might look something like this. Is that right? If I graphed it? Okay. It either goes that way or the other way. It either goes that way or that way. Oh, I think it goes this way. Yes? Does it go that way? Does it look something like that thing I have on the top? What? It has a limit. Oh, wait, it doesn't have a, I'm wrong, okay? I have a whole at 1. So 1 over x squared, I'm not sure what that looks like. Dude. Yes, sir.
I was just wondering how you got 1/3.
I plugged in 1 into this reduced form of the equation.
So you wouldn't plug in,
1 over 1 plus 1 plus 1, right? 1 plus 1 plus 1 is 3, right?
how did you get, for the, when you plug in, how did you get plus x instead of minus x? So do you not plug in negative 1 as, b? Because it says x cubed minus 1. So then when you plug in negative 1 as b?
No, it's just the root.
No, because this factors to this, right? X minus 1 times that, and then the x minus 1's.
So you disregard the sign, you just use
Wait. Okay, so this graph basically looks like that, except, because this is the graph of 1 over x squared plus x plus 1. It looks exactly like that, except right here at, well, where'd it go? Right here at 1 comma 1/3, I have a hole, okay? That's basically what's going on, okay? The function is undefined at that 1 comma 1/3. But as I approach 1 from both sides, I approach 1/3 in my y. Yes, Olivia?
So the answer would be like the limit is 1/3, and would you say there's a hole at 1?
You don't have to say there's a hole. They're just asking you for the limit, okay? So, okay? Yes? Moving on? Should I move on?
It's the bathrooms.
What?
Dave's the bathroom.
Yes.
Thank you.
The bat room.
Yes.
Are you gonna go change into Bruce Wayne?
I got something to do.
Oh, you're gonna use, not the bat room. Oh, the bathroom. Sorry. Okay. The bat room. That's where Bruce Wayne changes into his costume. All right. All right. Moving on. Oh, we're gonna need a break soon. Okay, what if I have the limit of the, these look ugly. X plus, I love these ones. So I love these like they're my own children. Okay. Over, whoops, minus square root of 2, okay, over x, wait a minute. Oh, yeah. Over x, and then you want to find the limit as x goes to 0, okay? So again, I'm not sure exactly what this looks like, but if I plug in 0, I get undefined there, right? Okay, so I can't just plug in 0 and have a limit and find a limit. So I can't factor the top, but I could do something else. Who sees something else I could do? Multiply by the conjugate. Very good. Conjugate. Okay. So if you see something like this with a couple of weird square roots like that, what you should probably do is multiply the top and the bottom by the conjugate of the top, okay, which is square root of x plus 2 plus the square root of 2, okay? And I'm going to do that on the top as well. And every single time, I mean, it might or might not work. I mean, sometimes you have to try things and see if they work, you know, and if it doesn't work, then you have to try something else. You say, oh, I can't simplify this, and then, because your goal is to plug in 0 and come out with an answer, and you can't have 0 in the denominator, okay? So let's see what happens here. If I multiply by the conjugate of the top, on the top, this times this takes away the square root sign, right? Which gives you x plus 2. This times this gives you minus 2, right? And these two inside and outside, the reason I multiply by the conjugate is because the middle terms disappear, right? So that's what I have on the top. And I'm just gonna leave the bottom alone for right now, because people want to immediately multiply that out. Because don't multiply it out, because things are gonna cancel out, you see? Okay? And then, this is the same on the top. This is equal to, you should keep writing limit, okay? Limit as x goes to 0 of x over x times the square root of x plus 2 plus 2, right? Who's root of 2? And now, what can I do? Now I can cancel out the x's. So that becomes a 1. And now I can plug in my 0, right? Well, I could just plug it in one place. So I get 1 over root of 2 plus root of 2, which is equal to 1 over 2 root of 2, which is the limit. If you want to rationalize that, which you probably should to make it look better, multiply by the square root of 2 over square root of 2, which gives you root of 2 over 2 times 2, which is root of 2 over 4. Okay? That would be your good, nice limit answer. Okay? Any questions on that? Everything that you learned from first semester? I'm sorry. There is some trick stuff on here. And so if you see something like this, so this one, limit as x goes to 0 of 1 minus cosine x over x. In calculus, you'll learn a very, very easy way to do that one. Basically, you take the derivative of the top and the bottom, which is it you'll learn to do, and then you plug in, and it becomes easy to do it, okay? But in this case, you don't really know that. But some other techniques that you might try with this type of problem is, I'm going to show you one in a minute. This one you can't multiply by a conjugate or anything, because you're still going to have an x down here, and it's still going to be undefined, okay? But I'm going to show you one in a minute where you can actually do some trig to simplify the equation. But in this case, the only way really we know how to do it, because I plug in 0, I get undefined, is to take your calculator and then zoom in, okay? So if I go y equals 1 minus cosine x, and for something like this, you want to be in radian mode, okay? Cosine x, already messed up. You got to make sure you put that in parentheses, okay? Where'd my 1 go? It wasn't there, was it? Second, insert 1. So 1 minus cosine x, but you got to put a parentheses around the top. Otherwise, it will just divide by the cosine x and won't divide into the 1 as well. So you put a parentheses on the top, and then you divide that by x. And then you go to mode, and you make sure you're in radian. And then you could do a zoom 6 and see what happens. Zoom 6, which is a 10 by 10 viewing window. That doesn't look very good, but so you might like zoom in, okay? Let's try zooming in. Zoom in 2, okay? Because I'm trying to figure out what's happening at 0. What appears to be happening at 0? It goes through the origin. And you don't have to, like, there might be a hole there, which there is, okay? But you don't have to worry about it, because you're looking for the limit. You're not looking for the hole, right? So the limit, just by looking at your calculator, this is -1, this is 1. And you can look at your table, too, right? Second table, you can see, whoops, second, I don't think I showed you this either. Second table set. You could set your table set so that you can set it on ask, okay? Then you don't have to worry about those other things. If I set my table on ask, then I could plug in values that are close to 0. Like I could plug in 0.01, okay? And then it will give me the answer. Do you see I'm close to 0? Even closer to 0 might be 0.001, right?
You just put the independent value on it. go there, you don't put a dependent
Right,
there.
and it tells you what the y value is, right? So this means 5 times 10 to the negative fourth, right? Which is a very small number. So obviously, or not so obviously, you're getting very, very close to 0 as x approaches 0. So the limit of this is 0, okay? And that's how you do it, okay? Okay, can we move on?
Yes.
So I did want to show you one where you actually have to do some tricks to do some stuff, because there's one like this on your homework. So this is kind of a good one. The limit as x goes to pi over 2 of 1 minus sine x over cosine x. 1 minus sine x over cosine x. There's a couple different ways to do this. What's the cosine of pi over 2? Cosine of pi over 2? 0. Okay? So that's going to give you 0 down here, so that's no good. But what you can do is you can multiply by the conjugate of 1 minus sine x. What's the conjugate of 1 minus sine x? 1 plus sine x. And I'll show you why I want to do that. Okay? Because sometimes this technique works. Don't multiply out the bottom yet, okay? Because then what happens is this turns into, on the top, I get the limit as x goes to pi over 2 of 1 minus sine squared x, right? 1 minus sine squared x over cosine x times 1 plus sine x. Do you guys remember from first semester what 1 minus sine squared x is equal to? Cosine squared x. See, you remembered something from first semester, right? As x goes to pi over 2 of pi over 2 of cosine squared x over cosine x times 1 plus sine x. I know this is evil, okay? But then what I could do is cancel out one of my cosines, right? So on the top, I have the limit as x goes to pi over 2. Once I cancel one of those cosines out, I'm left with on the top cosine x over 1 plus sine x. What's the cosine of pi over 2? 0. And what's the sine of pi over 2? 1. And 1 plus 1 is 2. What's 0 over 2? 0. So all that work just to get that the answer is 0. But that's what the answer is. Okay? Algebraically, that's what the answer is. Okay? So that's kind of a cool one. Would I give you something like that on a test? I don't think so. Okay? But it's kind of a good thing to know how to do. All right? Because it's always nice to not have to rely on your calculator. Okay? Oh, there's more. Do we need to take a break yet? Should we just pound it out?
How much left?
How much left? I think, okay. So, one-sided limits. We looked at this the other day. So, if you have a, I'm recording now, right? So, that absolute value function that kind of looks like this here and this here, okay? Where this would be 1, 0, 1, and this would be 0, negative 1. This would be a graph of y equals absolute value of x over x. Remember we did that the other day? And we talked about that. You may not, you say that the limit doesn't exist at x equals 0, but you can have a left-handed limit and a right-handed limit, okay? And so the limit as x, so this is red, the limit as x goes to 0 from the right side, if this is f of x, okay, is equal to, in this case, what value am I approaching as I approach 0 from the right side? Positive 1, okay? So this is from the right. So this doesn't mean positive 0. It means from the right, okay? That's how the right-hand limit, okay? From the right. And if I say the limit of f of x as x goes to 0 minus, okay, that's equal to -1, and this means from the left, okay? From the left. Oh, I didn't give you guys a chance to answer. But do you guys understand why it's -1 over here? Because as I approach 0 from the left-hand side, the y value that I'm approaching, okay? And what's really weird is that a function has a limit. Let me write this. F of x as x goes to c, okay? The limit of f of x as x goes to c is equal to L if and only if. That means it's true in both directions. That's what if and only if means. If and only if the limit as x goes to c from the right of f of x is equal to the limit of f of x as x goes to c from the left, okay? And that's equal to L. So what does that mean? It's kind of weird because it's kind of like you're contradicting yourself, but you're not really, okay? You can have a left-hand limit and a right-hand limit, but if they're not the same, then the function is said to not have a limit at that point, okay? So you could have a limit from the right, a limit from the left, but you don't have a limit, a general limit, if those two things are not the same. You get that? Hello? Yeah? Okay. So that's basically what that says. All right? Let's look at this piecewise function, and then we'll look at one more thing, and then you can work, okay? So for a piecewise function, say you have that f of x is equal to this piecewise function, x plus 2, that's a plus sign, not a 4. Okay? Oh, my thingy is x plus 4 if x is greater than or equal to 2.
I thought it was 2.
Oh, I did? I did, and that's what I meant to write. It's difficult when you x, but if x is okay, thank you. X, what should I put here? 2. If x is greater than or equal to 2, okay? And then x squared if x is less than 2. So this is, and you want to find the limit, find the limit of f of x as x goes to 2, okay? So what you have to do is it might help to have a picture of it, okay? But this says everywhere up until 2, I have the function y equals x squared. If I plug in 2 in here, what do I get out? 4, okay? So 1, 2, 3, 4. So up until this point, this function looks like this parabola that looks like this, not including this point. I should have made that an open circle, but it looks like a parabola, right? That's what y equals, not that, doesn't go through here, right? y equals x squared. Up until this point, I use this point. After this point, I use the equation y equals x plus 2. Well, what does y equals x plus 2 look like? A straight line. What is the value of this function at x equals 2? 4. So this other function starts here at, it starts here at the same point, right? And at this point it turns into that straight line. So this says up until I get to 2 I have this parabola, and after that it turns into a straight line. What's the limit as x goes to 2 of f from the left? What's the limit? What value am I approaching as I approach 2? 4, right? What's the limit of f as x goes to 2 from the right side? What value am I approaching? That's also equal to 4. Therefore, the limit, this means therefore. Did you know that? Those 3 marks? Therefore, the limit of f of x as x goes to 2 from both sides is equal to, hello, 4, right? So if this were 3, would this have a limit? If that were 3, would this have a limit?
No,
Instead of being 2, why not?
because it would stop at 5.
It would be, because if I change this to a 3, then this would be approaching 5 from the right side, and it would be approaching 4 from the left side. You get that? Okay? So if these two things do not connect at the point where the function changes, then it doesn't have a limit at that point. So if I change this to a 3, then the limit from the right would be 5, the limit from the left would be 4, and I would not have a limit, right? Get it?
So is there a difference between an equation that has a one-sided limit and an equation that doesn't have a limit, or do they both technically not have limits?
Say that again.
Okay, so like for the absolute value function you showed
Right.
us, it has a one-sided limit because it approaches
Yeah,
different
yeah.
values from each side. So if you switch that to 3, would it have a one-sided limit, or would it just not have a
It
limit?
would have a one-sided limit.
Oh.
Yeah, it'd have a right-hand limit, left-hand limit. So that, I mean, if I graph this function like this, it would look like this, and this would be the point 5, right? And then then it would turn into a parabola, and then it would look like this over here. So I would be jumping, so if you have a jump in it like that, then at that point, then it doesn't have a limit.
Okay.
Okay? I could have a limit here, but I won't have a limit at that, it's called a discontinuity.
And so
Okay?
if you like
I
ask
jump.
us, if
What?
you ask us to like find a limit of an equation like that,
I will say find the one-sided
so
limit.
you'll say
Yeah.
find the, and then if you say
Yeah.
find the limit,
Yeah.
it doesn't have a limit.
Right. So this one would not have a limit, this one does have. Okay. Now here comes the last thing that you're really gonna love. I love it, but you know, this is you'll learn this in calculus next year, but we teach it here, okay? Right here in advanced pre-calculus, okay? So this they call a limit from calculus. This is my favorite thing, by the way. Well, not as good as Chipotle Friday nights, but it's still pretty good. A limit from calculus. Okay. And you'll say, what the heck does this mean? So for f of x is equal to x squared minus x, find the limit as h goes to 0 of f of 1 plus h minus f of 1 over h, okay? And if you see this will be on your test, it will be on your quiz, it will be on your homework, okay? And you will see this numerous times next year, because this has a specific name, okay? This is the definition of a derivative. I won't talk about it yet, okay? But basically, what you're doing here x squared minus x. If I were graphing it, y equals x squared minus x. Let's see, I have x, and then I have x minus 1, right? It has a 0 here at 0 and has 0 here at 1. Basically what you have is a parabola, right? Okay? Vertex is at 0. Oh wait, vertex is at 0, 0, 0, right? Is that right? 0 is. No, the vertex isn't at 0, 0. The vertex is at, never mind. Vertex is at 1/2 comma something. Don't worry about where the vertex is. Basically what you're finding here is at 1, okay? So say I were to blow this up. Here's 1. Here's another point on this graph, okay? You don't have to worry about technically what you're finding, okay? I just kind of want to show you what you're finding, so it might be more interesting to you, okay? What you're finding is the slope of a line, okay? And the slope of that line as it goes from this point where x is equal to 1, okay, to x is equal to 1 plus h, okay? So if I go from 1 to h, this point would be 1, this point would be 1 plus h. Yes? Okay? So what you're finding is the slope of this line from 1 to 1 plus h. But as h gets smaller and smaller and smaller, this line is going to get closer and closer and closer to being, this point is going to get closer and closer and closer to this point. You understand that? Okay? And so if I put this in again, okay, if I made h smaller, as h gets closer and closer and closer to 0, this line actually, it gets closer and closer and closer to the exact slope of the curve at that point. Do you understand that? Okay? And when you're finding a derivative, that's what you're finding. You're finding the rate of change of a curve at any point. You'll learn that next year, okay? But right now we're just worried about evaluating. Okay? So the way that you evaluate this, f of 1 plus h means take 1 plus h and plug it in both places into this function, okay? So this is equal to the limit as h goes to 0 of 1 plus h squared minus 1 plus h minus, what's f of 1? What do I get if I plug in 1 in here? F of 1, plug in 1 in here, what do I get out? 0, okay? That whole thing over h. You understand what I just did, everyone? I took 1 plus h and I plugged it into my original function, which is f of x, which is x squared minus x, right? Yes? No? Just bear with me, okay? Then I'm going to FOIL this, okay? So this is equal to the limit as h goes to 0 of 1 plus 2h plus h squared minus 1 minus h. Because I distributed through, the minus 0 I'm not going to worry about. And I can put an h down here. Yeah? Okay? What can I cancel out? What goes away? What goes away up here? What could I cancel out? I could cancel out a 1, right? I can't cancel out too much more yet. But I have, that's equal to the limit as h goes to 0 of 2h minus h. What's 2h minus h? H plus h squared divided by h. Now what? What could I cancel out from the top and the bottom? H goes in here, h goes also in here. So I could rewrite this as a limit. What's wrong with h?
It just sounds weird. It's
H?
like one of those words that how do you spell it?
I have an h in my side. H. So then what I can do, watch. This is equal to h times 1 plus h, right? over h. Do you understand that? Now I can cancel out these h's? Yes?
Yeah.
Now I have, this is equal to the limit as h goes to 0, h, I don't think it says that word, of 1 plus h. What happens when I plug in 0 in here? What do I get out? 1. Okay? I couldn't plug in 0 over here because I would have got undefined, right? So now I get 1. So what does that tell me? That tells me in this curve, okay, that I just sketched for you, okay, at 1, the slope of that curve is what? 1, okay? So the slope of that curve is 1, which is pretty cool because you can figure out the slope of a curve at any point, right? So you don't normally think of a curve being sloped, but right, it's getting steeper. And like if this is a rocket taking off or something, that can tell you how fast the rocket is because it's the change in distance over time, right? Or if it's change in speed over time, you're finding the acceleration, and you could go backwards. And so what we just did there is we found the derivative of this function at x equals 1. I could do the same thing and plug in 2 and find the slope of the curve at 2. I could find the slope of the curve at -5. I could find the slope of the curve at 6. And you would expect it to be steeper using exactly the same technique. It kind of, oh, that, this is what people have a really hard time with. But anyone want me to go back through anything they didn't understand in this part of it? Yes?
Why did you subtract 0?
Because that's f of 1, right? F of 1, it won't always be 0, but in this case, if I take 1 and I plug it in, right? F of 1 plus h minus f of h. F of 1 is 1 squared minus 1, which is 0. Okay? So really what you're finding, how do I find slope? How do I find slope? What's the equation for slope? y2 minus y1 over x2 minus x1, right? What? x1, right? This is y2, right? This is y2. What I get when I plug in there, this is y1. H is x2 minus x1 because it's the distance between the second x point and the first x point, right? You'll learn more about that when you get to calculus, but just all you have to worry about right now is how to do this, okay? So if this were like a 3 here, Olivia, like if this were a 3 here, then f of 1 would not be 0 anymore. F of 1 would be 1 minus 1 plus 3, right? It'd be 3, yeah? Okay, you understand? Okay. And so it's not always going to be 0, that f of, but you'll get some practice. Okay, I'm done with my short lecture for the day. Only